Hello and welcome to a Maths with Harry lesson. In this video, we're going to have a look at the equation of a straight line. The majority of this video you might have seen at GCSE before, apart from the end section. What we're going to do is have a look at a different form of the straight line at the end. What we will first of all do is kind of recap a little bit of GCSE work. And the first thing we're going to kind of recap is what is the gradient. So here I have a straight line, okay? I actually have part of a straight line because really the straight line continues forever, okay? I've just took a section of that straight line. Now you can see I've got some components here, some components on the right hand side, and I'm going to add those to my straight line. So I'm going to choose one point to be at each end of the straight line, and I'm going to call this red point down here x1, y1, and I'm going to call, this point up here x2, y2. Okay, now you might not have seen subscript notation before. This x1, y1, this little 1 down here, is a smaller one. It's called a subscript. We just take x1, and that's different to x2, which is different to x3, x4, etc. It's just so we don't have the alphabet, basically. We can still have x's with a little subscript to differentiate them, okay? And similar for y1 and y2. So those are 2 points there at the end of my straight line. What I want to do is I want to work out the gradient of the straight line. So what I'm going to do is I'm going to have this straight line just to kind of mark the vertical change. This might be ringing a few bells. And this horizontal line to mark the horizontal change. These two lines meet at a right angle, okay, and we've got 2 points there. To work out the gradient, what we do is we work out the change in the vertical direction, so the change in the two y coordinates of these 2 points. Then we work out the change in the horizontal direction, or the change in the two x values of these 2 points, and then divide them. Okay, so we can see quite easily that if we take the y values, okay, we can see the change in those, and I'll write this in yellow, is y2 minus y1 to work out the difference, if you like, okay? We started at y1 and we've ended up at y2 on the straight line, so what's the change? Do y2 minus y1, we'll work out the change in y. And then the horizontal change, well, we started off at x1 and we're now at x2, okay, so to work out that difference, we'll highlight those in green. To work out that, we'll do x2 minus x1. Okay, and then to work out the gradients, we'll do this calculation. The gradient is y2 minus y1 divided by x2 minus x1. That is how we work out the gradient. Okay, that's not the neatest straight line. Let's do that, that's better. And let's take off the fill so we can see inside. Okay, that's how we work out the gradient. It's just the difference in the y divided by the difference in the x. Okay, so let's have a look at an example. We've got 2 points here and we want to work out the gradient of the line joining the 2 points together. Now we can basically follow this formula, if you like, to work out the gradient. We can just substitute those values in. But at A level, it's quite nice to see why that works. And to really help us, we're going to draw a quick graph. So let's draw our y-axis and let's draw our x-axis like that. And let's put some points on there. I'm just going to move that over a little bit. Okay, so the first point I will do in red, so let's draw that on. Minus 2, 7. Minus 2 in the x and 7 in the y is going to be somewhere there, okay? Minus 2, 7. Then in green, I will draw 4, 5. So 4 in the x direction and 5 in the y direction is going to be somewhere there. Not perfect, just a quick sketch. Then we will join those points together, and I won't use black because that's what the axes are, I'll use grey, okay? We can join those points together there. Now, hopefully you can see from what you've learnt at GCSE that straight away we can see this gradient is going to be negative. And that's because we're starting at this point here. You also look at it like you're reading a book. You go from left to right. We're starting at this point, and we can see the line is going down the page. So it's going to have a negative gradient. It's going down, so it's going to be negative. Here, this line, well, we start at this point, x1, y1, we start at the left, and we go up the page as we go to the right. So this is going to have a positive gradient. But going back to the example, we're hoping for a negative number, a negative gradient. Okay, so I'm going to add a dashed line across there so we can kind of have a look at the horizontal change. And I'm going to have a line going vertically downwards like that to work out the vertical change. Okay, so we're starting at this point here and we're going down to this point here. So the point that we start at, we call x1, y1, okay, if we're thinking in terms of the formula. And the point that we have here is x2, y2. Okay, to work out the change here, remember what we do is we do y2 minus y1. So let's do that. y2 we can see is 5, so y2 minus y1. y1 we can see is 7. That is minus 2. So the vertical change is minus 2. I'll just have a look at the horizontal change, and then I'll just discuss a quicker way we might be able to do this. Okay, the horizontal change, well, we can see we are at minus 2 here. I was looking at the y, then we want to look at the x's here. Minus 2 and 4. So I'm going to do x2 minus x1, just like what we have here. Okay, so x2 is 4, and then minus x1, so minus 2, I'll put brackets there, that gives us 6, because that's 4 plus 2. Okay, so I can see my horizontal change is minus 2, using the formula, and my vertical other way around, sorry. My vertical change is minus 2. My horizontal change is 6. And we got there using this formula, kind of considering the 2 points, taking them away. Another way we could have done that, which is quite a lot quicker, is just thinking, right, we started with the y value of 7, we finished with a y value of 5, because we're going down the page here. This was our first point, this was our second. From 7 to 5, we've gone minus 2 in the y direction, because 7 to 5, minus 2. Here we've gone minus 2 to 4, so we've added 6 to the x direction from minus 2 to 4, so we're going to have an x change, of 6, okay? And then we can just divide them, but if you like to use the formula, you get the exact same answer. So that tells me that the gradient, which we usually denote as m, that's going to be the change in y, which is minus 2, divided by the change in x, which is 6, and then cancelling, we can get minus a third from that. And then that is our answer. Okay, checking the book, minus a third is correct. Okay, let's have a look at another example. We've got a line joining 2 points, 2 and minus 5, to another point, 4a, and that line has a gradient of minus 1. We want to work out the value of a. So to do that, I'm not going to draw a diagram here, I'm just going to consider the formula. I'm going to take one y value and take that away from the other y value. So I'm going to consider this point to be my first point. I'll highlight that in grey. Okay, that's going to be my first point, my x1 and my y1. Okay, and then this point is going to be my x2 and my y2. I've just chosen that right now. Okay, you don't have to. You could have done it the other way around, but that's what I'm going to do. So What I've got is x1, y1 and x2, y2. Don't know why I've chosen it that way. You can choose it the other way if you want to. So the formula says y2 minus y1, so minus 5, and we'll call it gradient here. Okay, the gradient of the line joining those 2 points together, or the line that connects those 2 points, is going to be change in y, so minus 5, because that's y2, minus y1, which is a, divided by the change in y, x2 minus x1, which is 2 minus 4. That's what the gradient is, but we actually know what the gradient is. It's minus 1. So this is how we can work out the gradient. If we knew what a was, we could just work out the gradient and get a value, but we don't know what a is. But some value of a gives us a gradient of minus 1, okay? So what we now really need to do is simplify and solve for a. It's that simple. So 2 minus 4 on the bottom will give me minus 2. So we'll have this like that is equal to minus 1. Multiply up by the minus 2, so minus 5 minus a is equal to 2. And then we'll have minus a is equal to 7, so a is equal to minus 7. And then that is our value for a. So all I did is use the formula. I just called one of my points x1, y1, and another one x2, y2. Worked out the change in y, divided that by the change in x, and set that equal to the gradient that we were told, okay, because that is exactly what we needed to do. Okay, let's combine the gradients and the equation of a straight line together to give us the equation of a straight line, or combine gradients and a straight line. So when we do that, we get this. Y is equal to mx plus c. And this is a little recap because this is what you've seen at GCSE before. Y equals mx plus c is the equation of a straight line. M here is your gradient. M is the gradient of your straight line. And c is the y-intercept. I shorten that to y-int, just because I can't bother writing y-intercept, okay? So if you have an equation like this, y is equal to some multiple of x plus c. C might be negative, so you might have minus c. But if you've got something in this form, then you can graph it as a straight line, where the coefficients of x, the number outside of x, is the gradient, and then what we're adding on is the y-intercept. Okay, so first of all, I've got 4 examples here before we get on to an official example. These are just quick examples. I want to read off the gradient and the y-intercept. Well, all we have to do is compare it to this form here. And what I'll do is I'll bring that down so we can still have that in view. So, example 1, y is equal to 12x. That is just going straight through the origin but multiplied by 12. Y is equal to x scaled in the vertical direction of a scale factor 12. Okay, we've seen that in previous videos. So what's the gradient of that? It's just the number outside of x. So that means the gradient, which we'll call m. M is 12. And then what's c? Well, we can clearly see z. C, not CZ, that Z is 0 because we've got a plus 0 on here. We don't need it, we can get rid of it. So those are our values of the gradient and the y-intercept. Okay, here we have 2y is equal to 4x plus 6. So I'm going to divide everything by 2 to tell me that y will be equal to 2x plus 3. And then I can read off what m and c are because we've got y on the left-hand side. If I was to read off 4 and 6, that's incorrect because we have a 2 outside the front here. So I need to get y on its own first. Divide by 2 to then tell me that the gradient is 2 and the y-intercept is 3. Okay. Example 3, x plus y is equal to 9. What we want to do is, first of all, work out what the gradient is and the y-intercept, but we'll do that first by getting it in the form y equals something. So all I'll do is I will just minus x from both sides, And then I can read off m to be the number outside of x, the coefficient of x. Well, that's easy. M is -1, and then c is just what we're adding to the function, is a 9. So c is 9, okay? Now, notice here, if I actually was to write that, and I'm just going to amend that a little bit for the minute. If I wrote that like that, that is actually in a form that is recognised in maths as the integer a solution, or the integer equation, okay? That's the integer form of the equation of a straight line. What we have is a 0 on the right-hand side. We have x, we have y, and we have our constant, all as integers on the left-hand side, okay? Now, to read off the gradient and the y-intercept, we want to get it in the form y equals mx+ c. So I'll go back to that, okay? And I want to get y as the subject here. So what I'll do is I'll minus 3x from both sides to give me that, okay? And then I'll divide both sides by -8. So we'll have 3 over 8x minus 7 over 8. And then I can see the gradient here will be 3 over 8, and the y-intercept will be minus 7 over 8. Okay, so quick examples of just reading off the gradient and the y-intercept. Okay, let's have a look at, I think, oh no, not the final example. It's the final example of the quick recap in this video, and then we'll have a look at a different way of coming up with the equation of a straight line that's probably new to you. So, example 3 says the line y equals 4x minus 8 meets the x-axis at the point P. Work out the coordinates of P. So, nice and easy. Pause and have a go, and then we'll work through the answer. Okay, hopefully you got this one right. If you did, let's have a look. So, we want to work out the point P when P meets the x-axis. So we're on the x-axis, so we'll highlight this in red. Meets the x-axis, that means y is 0, because if we're on the x-axis, we've got no y value, so the y is 0. Okay, so at the point P, it's going to look something like this. We're going to have some x value, and y is going to be 0. So all we need to do is set y equals 0 into this equation. So y equals 0 means that 0 is equal to 4x minus 8. I've just replaced the y with a 0. And then I'm going to solve for x. I'll write that here. Solve for x. That gives me, well, 4x will be equal to 8. I can just add 8 to both sides to give me, well, 8 is equal to 4x. Flip that round, 4x is equal to 8. So that tells me that x is equal to 2. So therefore, P is at 2, 0. And that is our final answer. Okay, let's just check that is correct. That is perfect. Okay, now another form of the equation of a straight line is actually easier to use. If we've got the equation of a straight line with gradient m, and it passes through the points x1, y1, the equation can be written like this. Y minus y1 is equal to m times x minus x1. So we've just got one point here, and we've got the gradient. And that's what's quite good about this form. We just need one point and the gradient, okay? Then the equation is y minus the y value equals m times x minus the x value. So let's have a look at an example of that. We can see we can use this form, and I would encourage you to use this form as much as you can during A-level maths. We've got a gradient of 5, and we've just got 1 point. The equation is y minus y1 is equal to m times x minus x1. Those are your x and y values of the 1 point that you've got, so this point here. And then this, which we'll highlight in green, is m, that's the gradient which we've got there. So all you need to do is just a game of substitution. So pause and have a go, and then press play, and we'll work through the answer. Okay, hopefully you've substituted correctly. Let's see what you've got. We can see we've got x1, y1 here as our point. So we're going to have y minus y1, which is 2. M is our gradient, which is 5, times x minus x1, which is 3. And we can kind of leave our answer like that. We don't have to do anything else to our answer. It has not specified what form they want our answer to be in. So that is an appropriate form for our answer. It could also say in the form y equals mx plus c. So we'll do this in grey. We could have y minus 2 is equal to 5x minus 15, and then add 2 to both sides. Y will be 5x minus 13. That is another appropriate form, but like I mentioned up here, this is also an appropriate form if we had minus 7 to be equal to 0. That is an appropriate form, okay? That's the integer form of a straight line, okay? This here. So we could get our answer like that as well. So let's try that, okay? We could expand on the right-hand side to give me y minus 2 is 5x minus 15, and then get the right-hand side to be 0. So we'll have y minus 5x plus 13 is equal to 0. And that is another solution to the question. Okay, that's another equation of the line. It's exactly the same equation, just given in a different form. Okay, so we can have this here. We don't need to do any simplification or expanding unless they specify. You could have it in our general mx plus c form, or we could have it in our integer form. Okay, all of our numbers here are integers, as you can see. 1, minus 5, and 13. Okay, the final example for this video, we've got 2 points, and I'm going to add something to this question. I'm going to say, giving your answer in integer form. Okay, in other words, a times x plus b times y plus c equals 0, where a, b, and c are integers. Okay, so pause and have a go. Use the other form, the y minus y1 is m times x minus x1, to have a go at this question. Okay, hopefully you've paused and hopefully you managed to get it in integer form. So we're going to have y minus y1 is equal to m times x minus x1. Here we've got 2 points and we don't know the gradient between them. So first of all, let's work out what m is. It's going to be the change in y, so I'm going to start with, let's start with this point, okay? Starting with this point, change in y, 7 minus the other y coordinate, minus 1, divided by, again, we're going to start with this point because they need to kind of match up. We started with this point for the y's, so let's start with this point for the x. 5 minus 3, like that. So we're going to have 8 over 2, which is 4. So we've got a gradient of 4 here, so that's my m value. Okay, that's going to go there. And then because we've got 2 points, we can pick either point that we're going to use. I'm going to use this point as x1 and y1 so that I don't have to deal with this negative. Okay, so let's substitute those in. Y minus y1 is 7 from there, equals m, which is 4, times x minus x1. The x point is 5, so minus 5. And we want it in integer form here, so we're going to expand. Y minus 7 is 4x minus 20. And then I'm going to add the 20 to both sides and minus the 4x to give me minus 4x plus y and then plus 13. Is that correct? I think so. 20 minus 7 is 13. Yes, so that is the integer form of our straight line. So that is then your final answer.